Okay, here we're trying to tow a 1,200 kilogram car with rope. The maximum tension force that the rope can exert is 1,970 newtons, and we want to know what the maximum acceleration that the tow truck can have as it drives, so that we don't break the rope. So there does have to be something attached on the other side here. Otherwise, there wouldn't be any tension in the rope. So we have the car, we have the earth, we have the rope, we have the truck. So the car is being pulled by the rope tension, and the truck is being pulled backwards, actually, this with the same tension. So, that's why it's kind of hard to tow a car, right? Or to tow anything, because you have this force pulling backwards on you. The earth exerts a weight force on the car, and there's also a normal force there pushing up on the car. There are some forces between the truck and the earth as well, but we're going to stop here because we only care about the car. We have all the car interactions. So for the car, we have that normal force up again, the weight down. Those are balanced because we're not accelerating vertically. And then the tension is unbalanced. I'll take up and positive to be the right and write my net force equations. In the x dimension, all I have is the tension. Since that's unbalanced, this must equal the mass times the acceleration. In the vertical dimension, I have the normal force up and the mg down, and those are balanced, so this equals 0. So what we want to know is what the maximum acceleration can be. So that means we're going to be dealing up here, and if I go with the maximum tension, what I will get is the maximum acceleration. So I'll have to do my solving here. 1,970 newtons. We want to divide both sides by 1,200 kilograms. So that'll give me a number of newtons per kilogram, which is equivalent to meters per second squared. 1.64 meters per second squared, which is not overly quick acceleration. This is a really bad plan, by the way, to tow a car, because when the tow truck tries to stop, the rope cannot exert a normal force backward on the car, so the rope will go slack, the tension force will go away, and the car will slam into the back of the tow truck. That's why those, if they're towing it with something, it's a rigid bar instead of just a rope.